What I wish to know from all of you is, can you help me write or draw free body diagram for this cuboid? This is the cuboid which I'm into referring. This cuboid is made up of water. By that what I mean, it is part of fluid, just being highlighted as we are to write FBD for it. Free body diagram. It is floating, of course. What will be FBD for it to be presented is in terms of its mass. So mass we are known to rho, if is the density, multiplied with volume. Volume will be alpha into dy. This is to get me mass, multiplied with g gets weight. This is the weight of the water cuboid taken here. We show it with vector. This is rho alpha g dy. Rho alpha g dy is what we have to see. Other than this force, there are two forces. Altogether, there are six forces on six faces, but they being balanced, let's say, as there is no movement in the horizontal plane or xy, xz plane. The movement if, is to be seen against y-axis is what I'm into arresting. I don't have to do much with movement in xz plane. I'm to arrest or I'm to see for its being in state of equilibrium vis-a-vis y-axis. The other forces which are in y direction can be marked as, from top there's a force acting down, and from bottom there's a force acting up. So these are the forces. I wish we can write in terms of pressure. Would you please help me write them in terms of pressure? Pressure into area will get us force. Can we write them in terms of pressure? Yes, please, some help. What shall I write pressure as? Which pressure, according to you, should be higher? The pressure which is being applied from bottom, or the pressure which has been applied from top? Which pressure, according to you, should measure high? Yes, please. Okay. So can we write P plus dP for it? Can we write for that pressure, the one which is being applied from bottom, P plus dP? P plus dP multiplied with area will get me force. Do you approve of this, Vasudev? Okay, so this is being marked as P plus dP multiplied with area. I'll do later. P plus dP. Okay, multiplied with area we'll be doing later. We do it now, fine, into alpha. These are force from bottom and force from top will be P into alpha. Force from top will be P into alpha. If we are to go with these notations and write Newton's second law of motion, what do we get? Please specify. Newton's second law of motion is to get us what equation? Help me on the equation as well. Please take this part to be balanced. We are to get an equation over here which you are yourself to negate. Nevertheless, we need to make an approach towards it. Only then we'll come to an inference. P plus dP into alpha, P into alpha, and rho alpha g dy. These are the forces in their respective direction. Please go for algebraic addition, equate them to zero. Go for algebraic equation or addition, equate them to zero. So I am to take, let's say, downward force as positive. P alpha we write down. The other force in the downward direction being rho alpha G dy. Okay. Third force, which is in the upward direction, will be negative to us. So minus of, it was P plus dP into alpha, which will get me P alpha minus of dP into alpha. Do check class is equal to 0. Are you convinced with this equation? All of you? P plus D alpha being P plus
Yes,
dP
sir.
being force multiplied with alpha is force to us. Right, dear? Shall we proceed?
So I did not understand
Mhm.
because this means that the object that we took as the cuboid was floating, right?
Yeah, it was floating.
So
The
what have we
object was
taken
floating.
D?
It's a cuboid. It's not a foreign object, Mehul. It's an object which for us is part, and the part being very much of fluid. This part being highlighted to facilitate study.
Okay,
It's not a foreign object, right?
okay, sir, got it.
Okay. So P alpha got struck. We get from here dP equal rho G dy. You get from here dP equal rho G dy. We check our trot and go for integration now. Integration is what I'm going for now. Integration. We know pressure at height capital H. At height capital H, pressure is atmosphere, so P naught. P naught is the pressure at height capital H. What is capital H to me? Capital H is the trot filling water up to. Trot filling water up to. This is capital H to us. So at capital H, pressure is equal to atmospheric pressure P naught. That is what I have written. H, capital H, pressure is equal to P naught. I have to write it as function of y. So what I am to do here is y for me. I write pressure to be P at y is equal to y. Mind you, y is the measurement from bottom. Y is the measurement from bottom. So from bottom, this distance is what I'm referring to y from bottom. As I am measured from bottom h, I am measuring from bottom y. What then we end up getting is, you can see for yourself, P minus P naught is equal to what to us from here, this equation. P minus P naught is what to us? Is to us rho G, bracket open. What do we get from here? Y minus H, correct dear? Do check Y minus H. Convince all of you, Y minus capital H, yes or no? P minus P naught is equal to rho G Y minus capital H. Convinced here, all of you? Is it fine? Do I have all? P minus P naught is equal to rho G Y minus H. Now
Yes,
what
sir.
will this first? Yeah. Yes, please. Yes. Is anyone speaking? Are you all there? Mehul, Ishita, Shaktam, Vasudev?
Yes, sir.
So no, none of us said anything.
Okay, so P minus P naught is equal to rho G Y minus H is what we got, correct? I rewrite that equation. P minus P naught, P minus P naught is equal to rho G Y minus capital H is what we are getting. From here, what we get to see is P is equal to P naught and Y minus H. If I take H prime as H minus Y means from top, what distance it is from surface to be written. I will write H minus Y, surface, depth from surface H minus Y. And depth from surface H minus Y is nothing but minus of Y minus capital H. So what is this to get me is P naught minus rho G small h. Where what is small h? Small h is the distance or depth from free surface. Getting it, class? Isn't it? Is this what we are getting? Yes or no?
Yes.
Please.
So could you
Yes. Now,
tell me
what
what's
is this
small h?
equation then to suggest? Is as we are moving down, pressure is decreasing, correct? As we are, this is what it is suggesting. I'm not asking you to grow your brain over here, please. Please go by the equation, which is what it to be best read. This equation is suggestive of as we go down, as we increase on depth, pressure will decrease, correct?
Yes, sir.
Let me highlight what is small h to us. Small h is the distance or depth from top. That is what we have. Small h is the depth from top. Is it fine?
Yes, sir.
Okay. So if that's the case, small h being depth from top, we get it as P is equal to P naught minus rho G small h, right? Okay. Just a moment. Okay, then we'll rejoin with the same link. Okay, Vasudev? Okay. P is equal to P naught minus rho Gy. Vasudev, I wish you let me know why are we getting this weird, which we cannot certainly accept. Rho G small h. Let me write small h, which is what we have got. Can you suggest a correction here, Vasudev? As it was done on purpose for you to get me some knowledge on mathematics. Would you please help me on mathematics uses as we are somewhere going awry, leading to an equation which is suggestive of an inference not acceptable. Pressure doesn't decrease. What we got is with you, and for you to make an observation, pressure is decreasing. So on purpose, there was a part which I did assert on. I took your endorsement as well, both you and I would say Ishita, as the other two are slightly challenged on this part of mathematics. I took affirmation from both of you. You were in agreement with all that I did right, which led to this. So the part when I was referring to, you said P plus dP. Ishita said we did take P plus dP into alpha owing to pressure getting us higher force as we wanted to balance, which is a departure from calculus. Calculus doesn't say dP should be positive. So not necessarily P plus dP will be greater than P. dP is change, it can be positive, it can be negative. What in law of calculus states categorically is, if I have taken this part as y, lower as y, if this is y, and this part is y plus dy, top is y plus dy, then what certainly we have to keep to is, over here pressure should be P, and over here it should be P plus dP. We didn't follow or adhere to calculus. That's the reason we got a result which is not acceptable. Y will relate to P and Y plus dy will relate to P plus dP. It cannot be the other way around. We took the other way around, assuming P plus dP to be higher than P. Why? It was so incommensurate with our drawing on free body diagram stability, assuming P plus dP will be higher on quantum than P. We gave, of course, we didn't pay heed to calculus, throwing caution to wind, bringing back calculus into our calculation will yield us the correct result, which will be P is equal to P naught plus rho G small h. This being certainly acceptable is indicative of pressure increment as we go down. As we move deep, pressure increases. The other way of comprehending it will be pressure will increase in the direction of force application. Remember, I'll be using it later. The direction in which force is applied, pressure increases if one is to follow it. As force is in the downward direction, pressure as we move down increases. This increment is linear. It is a linear increment of pressure. We are moving for its application now. For now, nothing is in motion. This is static pressure to us. This is how pressure increases. We are dealing with dynamic pressure, sorry, static pressure. We are dealing with static pressure, I repeat. We are now to take actually a foreign element and see for the condition required on flotation. Flotation of this foreign element. Please write it down. Let us take a cube. Let us on which liquid force owing to pressure variation acts. Liquid force owing to pressure variation acts. Write an equation on balance state of, write an equation on balance state of foreign cuboid. Write an equation on balance state of foreign cuboid. Before I go into writing an equation, the other observation which I would wish all of you should be aware of is distinction between fluid and solid. The major distinction between fluid and solid relies on the fact that solid can bear force parallel to its surface. Solids can bear force parallel to its surface, whereas liquid cannot withstand force parallel to its surface. No force parallel to its surface can any liquid withstand. What does this mean? If I glue a duster, if I glue a cuboid on my palm, or if I glue one face of cuboid on table, this is the table which I'm referring to. This is cuboid to me. This is table to me. I have glued this face and I apply force F on its surface. What happened? Will the cuboid, which is solid in nature, in composition, will it be able to bear force? Will it be able to register this force? Yes, it will certainly. Will it be able to resist it? Now, this is something which we should be very cautious about because it's a bait. It's not that it'll be able to resist it. Of course, it will deform, it will deface. There'll be a, I would say, change, defiling of face, which we call grotesque. So there will be a face deformation. Face deformation, though with time, will decrease. This is where lies the distinction. This is where lies the distinction. In solid, there is deformation to take place, but deformation with time will decrease. That means the rate of deformation is decreasing, decreasing with time. This is in contrast with liquid or fluid. If you take fluid, let's say you have spread water, there's film of water, and you apply force on its top. This is a force parallel to its free surface. When I apply this force, it will not only get deformed, but rate of deformation will keep on appreciating, accentuating with time. This being the major, what we are then to rely is there being no deformation. This is what we say, though that's not in complete sense true. There is no deformation in case of solid. There is deformation in case of liquid. The inference drawn is no liquid or fluid can withstand force parallel to its surface. So when it's to be applied or optimize this concept, what do we get to see? Surface of fluid will always make an angle 90 degrees with net force. If it is not making an angle 90 degree with net force, it is not in stable. It is not in stable state. It cannot be in stable state. For instance, mg over here is acting in the direction, it will act in the direction shown. And surface of liquid, in order to be in state stable, should make an angle 90 degree with net force. Net force over here being mg, right dear? Right, all of you? Getting it? Okay. Let me now ask you on this elevator, when is placed it in to an acceleration A? This shot in an elevator placed into an acceleration A, moving, let's say, upwards as shown. What happened to surface? Will surface get reoriented, or will intact in orientation it be seen? What say you, Vasudev? What happened to surface of liquid? Will it go for reorientation? Okay. Say for meniscus, I'll come to Vasudev when we are referring to cohesive and adhesive force. Certainly this is not going to be the shape. I'll come to that later. Let us go by Mediterranean view. Mediterranean view means what you are to see the most. Not the brims, but what you are to see the most. Will that be maintained? Will it be flat, or is to change its orientation? Okay. What is your take, Ishita? Should maintain its parallel nature with ground, yes or no? Yes, Ishita.
I mean, if it's accelerating upwards, then the
Yeah.
apparent weight and the true weight are not equal.
Mm-hmm. No, I'm not
So,
going over there, Ishita. That is not my question. My question being pontificated, what will happen to surface is what being asked. Will it reorient or is to stick its neck out on what it was?
it would not reorient, I believe.
It will not reorient, it will remain same. Obvious, that should be the case. Why? Because net acceleration now in the vertically downward direction is g plus a. And g plus a direction being maintained, the surface will make an angle 90 degree to it. So there is not going to be any reorientation, not to be seen any reorientation, not to be seen any change in shape either. Whatever being shape is being retained, reorientation being ruled out. Let me then ask for a case 2, when I am moving it to the right. This is the body with me. This is the trot with me. That's a minute. Yeah. This is a trot with me. Is being moved to the right with an acceleration a. What say now? What say now on surface? Will it reorient? Will maintain its orientation? The trot is being moved horizontally to the right now. What happened to shape? Is there some reorienting into offing? Yes, Vasudev. Okay. So resultant acceleration, will it be aligned with resultant acceleration or will make an angle 90? Is what is to be answered in totality? Vasudev, will you come again on this? Okay, so A is in this direction, which is owing to some force. G is in this direction, which is also owing to some force. What do we then say? What is the direction of net force? Let us try to figure it out. If I keep it the way that I did, then there is a pseudo force which is to act on any particle. I'm showing it this way. This is the pseudo force acting on the particle, which to us is m into a, we know. Pseudo force is m into a. Okay. Gravity, m into g on that particle. Net force which acts on the particle being summation of gravity and ma, right? Summation of gravity and ma, which is to get me what direction? This direction. This is net force direction. Can we say that? The direction of net force. And we are aware of orientation that free surface should be at. Free surface cannot be stable in case there is any component of net force in the direction of free surface, parallel to free surface. In order to rule that out, free surface should be at an angle 90 degrees to the net force. Therefore, free surface is to take this orientation. This is how free surface will change its orientation, isn't it? Okay, so if we are to draw for the case taken, this is the trot. Trot is moving to the right with an acceleration a. Free surface is then to be seen the way that I'm drawing. This is the free surface to us. Let me dwell on this for a while and ask you, let me magnify this a little for me to get a better depth on it. Okay. This is the trot to me. This being the free surface. This point which I'm marking A is at a height h1 from free surface. Line parallel to horizontal housing this point which I have marked A is also to B. Okay. This height to me is h2. Okay. Acceleration to the right, it being A. This length is L to me. Done all. Now pressure at A, if I am to write one equation which is there with us known to both of you, all three of you, is P is equal to P naught plus rho G H1. Please do write PA. PA, pressure at A. You know which point I'm referring to, pressure at A. This is the point I'm in reference, this point. Pressure at A. Pressure at A is what to read? Pressure at A is to read P naught plus rho G H1. Similarly, pressure at B is what to read? B is P naught plus rho G H2. Fine, done. I wish to move from the top here, this point, down, vertically down, and then horizontally to P. I want to take this path. Help me in taking this path from here, vertically down, then backwards. I want to tread this path. 1, 2. The two paths shown over there. And an angle 90° and approach B. Could you please help me in writing of the equation? This equation being there, I'll come to it later. This is PB. I'm aware of PB. I have not followed the path which I indicated by bold. I have followed a path straight down, which got me this. Now I want to make an approach to B following path highlighted. Tell me what shall I write? How will I relate PA with PB following this path? Yes, dear. Tell me, Ishita, PA with PB, how will I relate? Following the horizontal line. Yes, Ishita.
Yeah, so they're on horizontal planes, so it will be equal, like PA would be equal to PB.
That'll be the case. That'll be the case when there is no force in that direction, Ishita. Right? That'll be the case when there is no force in that direction. That'll be the case when there is no variation of pressure. Are you of the opinion that pressure is not varying horizontally?
Okay, right.
Is there a force in the horizontal direction, which is what we have marked pseudo MA, yes or no?
Yeah, yes.
So pressure is ought to vary, right, Ishita?
Yes, sir.
So pressure will vary, and you're aware of pressure increases in the direction of force application, which is what to read PB will be greater than PA, right?
Yes, sir.
Which we are anyway getting. Now they are to be related differently. And for that I write PB is what to us is PA plus Vasudev, will you help me complete this equation? Rho AL, absolutely correct. Rho AL, right? Because in the horizontal direction, there is no trucks with gravity, we being aware of it. Only acceleration being A visible, force backward M into A will relate PA with PB the way that we did, right? This is also a to us capital A, let me write, in consonance with the symbolic representation followed. Tell me now, what do we get from here? We get two equations. First one is to read PB plus PA. This is also in consonance. PB minus PA. What is that to us? Rho G H2 minus H1 from these. Correct? PB minus PA from the above two equation will be what to read? Rho G H2 minus H1. And PB minus PA from this equation will read, PB minus PA from this equation will read what to us? Will read rho AL to us. Look at the figure. I'm back to the figure. Yeah, this one. This is the figure with us. Okay. Now, what is H2 minus H1 by L? This is the length which I'm into referring. Look at this, please. This is theta. If this is theta, then tan theta is H2 minus H1 by L, correct? Correct, yeah. Correct, both of you.
So
And H2 minus H1 by L is nothing but A by L as per our last two equations, correct? H2 minus H1 by L is equal to how much?
it will be
H2
A by
minus H1 by L is tan theta. We are aware of it, but as per the equation, what is it to equate? A by G. Can we say that? Please do check. I'm referring to this equation here, this one, dividing them, right? Is it okay?
yeah, yeah. Yes, sir.
But dividing them, we get H2 minus H1 by L equal to A by G, right, Rishita?
Yes, sir.
And which is what equated to tan theta as per the depiction. This is the angle by which surface will tilt. Tan theta is equal to A by G. Tilt in order to make the surface make itself 90-degree to net force. Why so? It cannot withstand any force parallel to its surface. A question to optimize this concept is coming your way. And the question is to read right down. Cork attached to string. Cork attached to string is kept beneath the surface of fluid. Is kept beneath the surface of fluid as shown. So this is the fluid that I'm into referring. This is the fluid. This is cork to me. And this is the string to which it is attached. Okay. We make now entire of the trot move to the right with an acceleration A. Entire of the trot is moving to right with an acceleration A. Options. String will bend to right. That is in the direction of acceleration. Option 2. String will bend to left. That is in the direction opposite to acceleration. Option 3. String will maintain its perpendicularity. And the last, data insufficient. Please come with one option. All of you should get me to the least one option. Is the question well received? Can I hear it from? Okay. Okay. The cork, certain density of the material that cork is made up of, liquid, the string being positioned over there is suggestive of, and certainly that's the case. Cork lighter in comparison to or lesser on density in comparison to liquid. It is held at the position with help of string. This is string to us. String is, for the time being, assumed massless and dimensionless. As we move trot to the right, which option you pick on?
I mean,
Yes, please.
if the beaker is given the acceleration towards rightward direction, so the water in the beaker will get acceleration towards right, and so the cork will also go towards right. I mean,
Okay, maybe can go to the right. Okay. Okay.
yes,
It's
exactly.
shown to
Is it
the
towards
right.
right? Yes, it's
You have your time, Vasudev, in case you want to change. I'm getting you getting both of you. To the right, whichever direction you position your answer to direction of acceleration, it will tilt in the direction of acceleration or opposite to it. Opposite to it. And Shita, your case being same direction as that of acceleration. Correct me if I'm wrong in comprehending.
yes, sir. I said that if it is given an acceleration towards the right, so the water in the beaker will also get the acceleration towards right, and so the cork will
Not water
also.
in the beaker. Entire of the beaker will get an acceleration to right. Water is not flowing in beaker, right?
Yeah.
There's no flow of water. I think that part being well taken, correct? Isn't there, Ishita?
Yes.
Okay. So to the right. And justification for taking it to the right being as the body is moving to the right. Sorry, as water body or entire of the trot is moving to the right, cork should also move to the right. Correct, Ishita? That is your justification.
Yeah.
If that's the justification, then you'll stick to that justification irrespective of what object being taken, right, Ishita?
Yeah.
So if I replace cork by an iron ball, your justification remains, right? Yes, Ishita,
Um,
I could
yes.
get a response. Yes? Is it a yes from you? Is an affirmation on this, Ishita? Do I have your concur on this, Ishita? I'm not getting you, dear. Yeah, could you please come again?
Just a second.
Just in case.
The density of the cork is less, right, than that of water.
And that's a
So
given. That's what I said. Yeah.
the pressure and the pseudo force, I mean, the pressure force will be higher and that is why done the pseudo force. So that is why it will go in that direction. Metal ball, not
A
sure.
metal ball? What about a metal ball?
I mean, why do I get confused right now? I think it will not.
Metal ball won't move per se, is it so? Zero it down quickly, dear. We are losing on time. I have already lost few seconds owing to my glitch.
Okay. No,
Yes, dear.
I'm like,
Yes, Ashita, what happened, dear? Cat caught your tongue. Come on, speak up now.
the metal cork would go in that. Sorry, I mean the cork would go in that direction. The direction in which the direction which the
I'm not
beaker
coming
is
to the
being.
direction. I'm not into over here getting to any inferences. I'm asking on the logic which you did place for. Your logic being liquid is moving to the right, so cork should move to right, isn't it?
Yeah.
We are aware of surface getting tilted, right? And to this surface, why is this surface getting tilted as net force is in the direction this? So surface got or made an angle 90-degree to it. If you let loose any cork, it will follow this line, right? It'll pop up following this line. Yes or no? It pops up when you take it this way, then it pops up vertically, moving vertically upwards, correct? Why? Because it'll move in the direction of force, correct? Similarly, this cork will move in the direction of force and pop up in this direction, or you can say the string will get aligned at an angle 90-degree to the free surface, correct? Am I good over here? Okay. So Royal being greater, I refuted Ishita on her answer. As you are aware of, answer to change when we take anything which is greater on density, higher on density than liquid in which it is being kept, correct? If I'm to dunk now a steel ball, of course I'll not do it from, again, you can leave it over here, but better is to arrange here this way. Right. And this is made to accelerate to the right. What will happen? What will happen? The steel ball will tilt backward, right? Yeah. Why?
Yes.
Because rho S VA will be more than rho L VA, right? Agreed?
Yes, sir.
So in this case, tiltation will be backwards. Okay. Question number 2. This is a trot which we have taken. There is a, just a moment. Okay. There is a cuboid floating in it with X part beneath the surface. This is the part beneath the surface. We make this rod accelerate with an acceleration A. It is kept in an elevator which is moving upward with an acceleration A. X will increase, X will decrease, X will remain same, data insufficient. X will increase, X will decrease, X will remain the same, data insufficient. Okay. Ishita, what say you?
Yes, it would not change
And why so? Why so, Ishita?
because it's moving with acceleration A upwards. So like there is some acceleration, right? I mean, um, the hold up, I'll
Variation of pressure will no more read P is equal to P naught plus rho GH. It will read P is equal to P naught plus rho G effective
Whatever
into
part
it.
of the volume that is being immersed in the liquid, so that depends on the density of the object, right? So
That depends also on acceleration, I would say. Net
yeah,
acceleration
but
is rho GH.
the system, the speaker is moving with acceleration upwards. I mean, acceleration
Yes, it is. It
with
is. Yeah.
with a system acceleration.
It is moving upward, downward. How does
Directing it
that do merit? Doesn't that doesn't merit? I'm asking about G. It depends on yes or no. To which the answer is straight off bat. Yes, it depends on G, and G now is
yes.
G effective, which is G plus A. If it is G plus A, variation of pressure got changed. Why are you then going ahead with the same eventuation? Nonetheless, think about it. We'll come back to it. The question is open to Ishita. If you are of the opinion that X is to remain, then what makes you come to this conclusion, right, Ishita?
Yeah.
Okay. Now we have to take a bend. Write down. Let us take a circular bend as shown in the figure. Let us take a circular bend as shown in the figure. Water flows in it. Water flows in it. With different levels. It's a horizontal one, mind you. With different levels as shown. As shown. If R is any intermediate position, if R is any intermediate position, answer the following. Answer the following. Question number one is asked for you to the one which is for you to answer. Question number one is if 1, 2, 3, 1, 2, 3 is what I'm marking the levels. 1, 2, 3 enters. Will 1, 2, 3 come out at the same time or there will be some time differential? 1, 2, 3, 3 particle did enter at the same time. Will they exit in unison or will be there some neck and top kind of a situation, one after the other? Vasudev, are you of the opinion they should come out with the same fervor or one is to lead the other? The streamline, fluid is flowing on a horizontal tube and it's flowing in layers, let's say. It's a streamlined motion. A streamlined motion of fluid. They are not crossing each other. They can be represented by one line. So streamlined flow being maintained. 1, 2, 3, enter. 1, 2, 3, enter. The 1, 2, 3 will come out at the same time or not, is the question. Will come out 1 first or 3 first. They are to come in one a unit. Okay, they'll come one after the other. Ishita, what's your take?
Yeah, that sounds right. I mean,
Ishita, please go by your own perception and knowledge. Shaktam, what say you? One, two, three. Will they come all at the same time? Okay, they are to come out at different time. Is what I'm getting two votes on. I'll go by majority. They are to come at different time. They will not be coming out at the same time. So
yes, sir.
if
Yes,
they
they
are
would
to
not be
come,
coming because
okay, so if they are to come at different time, Ishita, then which one will come first? May I know?
for one,
One will
correct.
come out first. Okay, one will come out first. I take that. One will come out first. So one will come out first if you are vouching for Ishita. It is suggestive of speed change from 1 to 3 or speed being constant. What are you suggesting? As they move in the tube, which is appearing to be a part of you, their speed will remain constant or it is to change. Will there be any change in speed, Ishita? See, one way of
Like, um,
standing logic to your answer. One way of standing logic to your answer would be one is to follow shorter length in comparison to three, right, Ishita? Yes or no?
I mean, if it's component wise, like
Answer to my question, Ishita, please. One is to follow shorter length in comparison to three, right, dear?
no.
No, one is not to follow shorter length. This is length followed by one. You know that they are not to cross each other. This is length followed by three. Is not three to follow larger quantum length than one, Ishita?
Okay, yeah, yes, yes, yes. Three would travel more
Okay,
than
yes, you
one. So
want. Okay, yes, you're a thing and answer. So one is to follow lesser length in comparison to three. If they are to move with same speed, then your logic stands good
one would
here. That one is to take lesser time, therefore one will surface earlier to three. Taken, accepted.
yes. Actually, I was thinking about something else, like we're taking component arm.
So I'm coming to that only, dear. Are you in agreement with this arrangement of one
Yes,
maintaining its speed as does three? They will maintain their speed, right?
yes, sir.
Okay, Vasudev, what say you, dear? Will they maintain their speed or speed is to change? Mhm. Okay, density we are not changing. Whatever enters should come out, that is a given. Else there'll be a question on compressibility of liquid, density will get changed. So that intact, whatever entered is to move out. There is no two way about it. Okay, Vasudev, just pushing the envelope. What do you say about pressure, dear, along this line, the line that I have shown, this one inside of it? Will pressure remain or change? Yeah. If I move along this line, will pressure be maintained or is to see a change? What? I got it. At E, at the point A. Okay. So it okay, it will be maximum at the point closer to the origin, indicative of point which is being referred by radius A, correct? Okay, let us figure it out. Let us figure it out. Let me take a small segment of mass over here. Okay, very small segment of. We are aware of this mass will have radial acceleration at that point, right, dear? It is ought to have radial acceleration. Agreement? Yes or no?
Yes, sir.
Circular track, radial acceleration is a must. Tangential, we can have some discussions on. But radial being a must, we are to follow calculus. Here the pressure marked is P. Here the pressure marked on that element is P plus dP. Okay, we then write net force, see for yourself, we then write net force as dP into whatever the area of cross section, alpha, let us say. So dP into alpha is the force in inward direction, right? Is the I don't know dP is positive or negative, not known to us. We are just following calculus, which is what we did profess few minutes ago. R is represented by P, so R plus dr will be represented by P plus dP. dP into alpha is what we are getting then. Inverse is equal to what to me? Mass into acceleration. I'm taking the force in the inward direction. So dP into alpha inward is equal to mass into acceleration. For mass, I write rho. I write alpha as the cross-sectional area. I write dr as length. So this is mass into acceleration. I write it as v square by, let's say, r. Do check here. It's fine. All right. Yeah, all right. You did guesstimate it correct. Okay. So revaluation to whole water, alpha gone. You're aware of what is then our take. What do we get from here is an obvious. Please do check. dP is equal to rho v square by r dr. Though we are not yet done with pressure variation. For pressure variation, next I'm taking some liberties on equation out here. I would assume Bernoulli's theorem being known to you, which is what to say, P plus rho GH plus half rho V square is equal to a constant. H over here doesn't merit a consideration as it being kept horizontal. So P plus half rho V square is C to us. We differentiate it to get dP is equal to plus half rho V dV is equal to 0. Do check. dP plus half rho V dV equals 0. This is the equation when we have differentiated Bernoulli's equation, you say, or theorem equation. This is what we are getting. And above we got dP is equal to rho dr V square by r. Right? You get now how will V vary? Just substitute for dP, right, Vasudev? Substituting for dP will end up what he did hint on, that pressure certainly will change and pressure and velocity have inverse relation. Agreed? Agreed? Pressure and velocity have inverse relation. Increment in one will ought to decrement in the other. This will show you how is velocity varying with R. Could you please get me from here? How does velocity change with R? What is happening to velocity there? It is not remaining the same, correct? Correct, Vasudev? Velocity doesn't remain same. Velocity will decrease as you move on the line which was shown, correct? Okay, so we get from here velocity decrement and pressure increment on the line which we were doing. Okay, dear, both of you clear here? Clear till this point?
Yes.
I'm extremely sorry with the technical challenges which we had to face today. I'll see to it that it doesn't occur again. Thank you, both of you. Thank you, Shaktam. We're keeping to this. Thank you.
Thank you, sir.
Pressure, we are to see exactly how the pressure varies, shall we? We were to find what is variation of velocity. Shall we figure it out? How is velocity varying? But on velocity we are very much in consonance, Vasudev. Velocity we are very much in consonance. Pressure is increasing, right? Velocity is higher for for one, right? It is all to add. Length is less and velocity is also high, correct? Yeah, pressure is maximum at this point, right here. Wait a minute. Yeah, correct. The velocity is maximum here, correct? Yeah. It is aiding rather. Length is less and velocity is also high, correct? Answer remains. There is no contrary view over here, right?